Hello students, how are you all? Welcome back to Akshar ID Foundation classes. I am your chemistry faculty S. Mohan. Students, so today we are going to start the last chapter of 7th class IIT Foundation. Right? So in the volume 2, we have completed two chapters, that is chemical bonding, and second one is periodic classification, right? And this is the last chapter, that is introduction to mole concept. So it's a very important chapter, very important topics are there in the chemistry. The mole concept plays a key role, right? So let's see what is the mole concept. Okay, friends. So see here, you know that to measure anything, we need some unit. Yes. So for example, if you go to shop and want to purchase any sugar, then if you ask for sugar, then how much he asks, right? So then you say that's 5 kgs, 10 kgs, something. So kg is a unit, right? So similarly, if you go to the shop to purchase or to buy milk, then if you ask the shopkeeper to give milk, then immediately he asks how much. Then you say that you want half liter, 1 liter, 2 liters, 5 liters, something. So a liter is a unit, right? But how we can measure the chemical substance or atoms? So see, you know that any matter is made up of a tiny particles called atoms. For example, this pen is made up of a tiny particles called molecules or atoms, right? This already we discussed in the volume 1 and starting only, okay, during the introduction. Now this pen is made up of molecules, right? So many molecules combined here, so this matter is formed. Now I want to see the individual molecule of this pen, individual molecule of this pen, with what it's made up of. Can I see with my naked eye? No, I cannot see with the naked eye. Why? Because the molecules is very small, right? So here the size of the atoms and molecules in terms of nanometers. This also we discussed. Nano means what? 10 to the power of minus 9 meters, right? So our eye can see very clearly up to 10 to the power of minus 3, that's called millimeters. You can see the millimeter. And if our eyes is strong, sharp, then you can see up to 10 to the power of minus 4 also. It's a small, just like dot, okay? But if it is less than 10 to the power of minus 5, you can't see, you need to use a microscope. So that's what 10 to the power of minus 6 is called a microscope. Okay, we can see such as small particles, okay, whose size is less than 10 to the power of minus 6, we see the microscope. That is 10 to the power of minus 6. But here, the atomic size or molecular size generally expressed in nanometers. Nano means what? 10 to the power of minus 3. So it's very, very small, right? So now, if you want to count that atoms, okay, so one matter is given to you, and if you want to count how many atoms are there, can you able to count? Impossible. Means with you, with your eyes, okay, just by seeing them, can you count? Like for example, I've given some pens to you, and ask you count the number of pens. You can count. I ask how many students are there in your class. You can count. But if I ask you how many atoms or how many molecules are in this pen, can you count? Impossible. You can't. Right? So because atoms are very, very small. So here to count the atoms, one unit is required, right? So here that is called mole. That's called what? Mole. Okay. So mole is what? Mole is nothing but a particular number. Okay. Mole is nothing but a particular number, right? For example, how it is a particular number? Like if you go to the banana shop, okay, and you want to purchase the bananas, then you ask for dozen. Dozen indicates what? 12. If you want to purchase dozen bananas, so it indicates that you are taking 12 bananas, right? So similarly, a mole is nothing but it's a fixed number that is 6.023 into 10 to the power of 23, right? So, here students, here see, here how the dozen, see I am writing here dozen represents 12, right? 12, okay, 12 numbers, okay. If you want to take bananas, 1 dozen of banana, so 12 bananas. If you want to take 1 dozen apple, 12 apples. If you want to take 2 dozens of pomegranates, so 2 into 12, that's 24, right? So, how this dozen is fixed, the number that is 12, similarly, mole, okay, mole is nothing but a which consists of 6.023 into 10 to the power of 23. Okay. If I ask you that 1 mole of, okay, 1 mole of carbon atoms, 1 mole of carbon atoms. So, meaning what is that? So, 6.023 into 10 to the power of 23 atoms is equal to 1 mole. Okay. So, 12 bananas is equal to 1 dozen. So, I want 1 mole of carbons. So, what you are saying? 6.023 into 10 to the power of 23 carbon atoms is equal to 1 mole of carbon atoms. Clear? Now, for example, if I ask you 1 mole of oxygen atoms, then 6.023 into 10 to the power of 23 atoms of oxygen, okay, that is equal to 1 mole, 1 mole of oxygen. If I ask you not only for atoms, if I say that 1 mole of water molecules, water you know, liquid, right, water molecules. So, 1 mole of water molecules means what you need to say now? 6.023 into 10 to the power of 23 water molecules is equal to 1 mole. Clear? So, 1 mole represents a fixed number that is equal to 6.023 into 10 to the power of 23 particles. Clear? Any doubt? No? Sure. Now, you see students here, here 1 mole of is equal to 6.023 into 10 to the power of 23. Alright. Now, observe carefully here. I want 1 mole of oxygen atoms. Okay. 1 mole of oxygen. Alright, carbon, otherwise anything. Okay. Let's take carbon with okay, carbon atoms. Means what? This many carbon atoms. That is 6.023 into 10 to the power of 23 carbon atoms. Carbon atoms. So, this is equal to 1 mole of carbon atoms. Similarly, if I say that 1 mole of, okay, now I will write oxygen atoms. Oxygen atoms. That is 6.023 into 10 to the power of 23 oxygen atoms. Clear? If I say that 1 mole of sodium, okay, we'll take sodium, okay, sodium atoms means what? 6.023 into 10 to the power of 23 sodium atoms. Clear now? So, 1 mole means what? Fixed number. 1 dozen of bananas means 12 bananas. 1 dozen of apples means 12 apples. 1 dozen of pens means 12 pens. That is fixed. Now, 1 mole of carbon atoms means 6.023 into 10 to the power of 23 carbon atoms. 1 mole of oxygen atoms means what? 6.023 into 10 to the power of 23 oxygen atoms. 1 mole of sodium atoms means what? 6.023 into 10 to the power of 23 sodium atoms. Clear? Sure. Now, let us see the mass. Let us see the mass of this one. Now, if I ask you 1 mole of carbon atoms mass, I want. Okay. So, I will say why, but later. Now, 1 mole of carbon atoms mass is 12 grams. How many grams? 12 grams. So, 12 grams of carbon, if I take, 12 grams of carbon, if I take, that 12 grams of carbon consists of 6.023 to 10 to the power of 23 carbon atoms. Right. So, 6.023 into 10 to the power of 23 carbon atoms. If I combine together and if I measure its mass, what I'll get? 12 grams. Clear? If I measure the oxygen, 1 mole of oxygen atoms means 6.023 into 10 to the power of 23 oxygen atoms I am taking in one pan, and if I measure, then I'll get 16 grams. Right? Now sodium out there. So 1 mole of sodium atoms, this was 6.023 into 10 to the power of 23 sodium atoms. If I take, I will get 23 grams. How many grams? 23 grams it becomes. Clear? Now, number of atoms same, but mass are different. Naturally, because here if I say that one dozen of bananas, that is 12 bananas. 1 dozen of apples, 12 apples. But if I measure the mass, if I check the mass, does both the mass remain same? No. Here I am taking 12 bananas, this side I am taking 12 apples. So they are different. So mass will be different. Yes or no? Number is same, but mass is different. Clear? Now, so here 1 mole of carbon atoms mass is 12 grams, 1 mole of oxygen atoms mass is 16 grams, and 1 mole of sodium atoms is mass is 23 grams. Okay. So now these are the grams. Clear? Sure. Now you see students now, for example, here grams are written, no? So just remove the grams now. Okay, I am removing these grams. Carbon, now check, and you say what is the addition this one. Okay, so see now, this is carbon, here number is 12, here oxygen, number is 16, here sodium, number is 23. Can you recollect anything? Yes? Very good. So here, the atomic mass of carbon is 12, already we discussed. Atomic number is 6, mass number is 12. Oxygen mass number is 16. Sodium mass number is 23. That's all. Okay. So, mass number of any element is nothing but it's a mass of 1 mole of that atoms. Clear now? So, if I take the, see, you know the carbon mass number is 12. So, 12 means what? Mass number of the carbon is 12. Right. Now, 12 grams, 12 is there. Okay, that number if I convert into grams. So, 12 grams of carbon means it's nothing but a 1 mole, okay, of carbon atoms. So, you know that oxygen atomic mass or mass number is 16. So, meaning is that 16 grams of oxygen, if you take, it consists of 6.023 to 10 to the power of 23 oxygen atoms. And you know that mass number of the sodium is 23. The meaning is what? If I take 23, means if I take 23 grams of sodium, it consists of 6.023 into 10 to the power of 23 sodium atoms. Clear now? Did you understand? So, your mass number is nothing but it's representing the mass of 1 mole of that atoms. Clear? Right. So, this is very important to remember. Okay. So, now again I write here. So, this is grams, grams, grams. Okay. Now, here you see students here. Now, this concept we keep here. Now, let us see the one more concept. Let's go to the relative atomic mass. Okay. So, we go to this, we keep here only. Okay. Now, I am going to the relative atomic mass. So, I am writing RAM. What I am writing? RAM. RAM is what? Relative atomic mass. Okay. What is this relative atomic mass? Relativity, relative means what? Comparison. Relative means what? Like comparison. Okay. So, here we need something standard to measure. For example, if I ask you, what is your height? Okay, if you ask me, what is my height? Okay, then I'll say that my height is 5.7, means what? 5 feet 7 inches. So, 5.7 feet means what? The meaning is what? I am 5.7 times of a unit a standard unit, that is food. Okay, so 1 food, that is standard unit, and I'm taking that standard unit and I'm multiplying this is 5.7, so that my height I am getting. All right. The meaning is what? For example, see here, if I ask you, we are sitting in, okay, if you are sitting on your benches, okay, if I ask you, what is the size of your bench? Immediately what you do? You take the scale, 1, 2, 3, 4, you put the scale, and you can measure, and you say that if you are taking some big scale, 30 centimeter scale, normal scale, which you use in the classroom, small scales and big scale. Small scale is 15 centimeters, I think, and big scale is 30 centimeters, right? So I measure 1, 2, 3. Okay, if your table consists of 3 times of your scale, then you can say that 3 means 30, 30, 30, so total 90. So I say that this is 90 centimeters, sir. Yes. So 90 centimeters means what? You are taking 1 centimeter as standard one, and you are multiplying with 90. 90 times of 1 centimeter is equal to 90 centimeters. Yes or no? Okay, 90 centimeters means what? 90 times of 1 centimeter, right? If I ask you what is the length of your classroom, then you may say that, sir, approximately 10 meters. Okay, so 10 meters means what? 10 times of 1 meter. So you are taking 1 meter as a standard one, 1 meter as a standard one, and you are multiplying 10 times, so that you will be getting the length of this room, right? So here, then what should be taken as a standard one to measure the atomic mass? Okay, so here after many attempts, so listen here, after many attempts, it was finalized that 1/12 of carbon is taken as standard one. Means what? The mass of one carbon. Okay, carbon atom is it? So mass of carbon. And your carbon also, which carbon? So carbon exists in terms of isotopes. Isotopes of carbon exist. Isotopes means what? Already we discussed, I think. Okay, isotopes means what? Again, it is there here. I'll discuss. Atoms of same element with the same atomic number but different mass numbers. Okay, so they are called isotopes. Again, once again I'll discuss. So this is carbon C6, 6 and 12. So 6 is atomic number, 12 is mass number. Now this carbon is taken, so this mass of carbon is taken, and they divided it by 12. They divided by 12 because its mass number is 12. So it's divided by 12. Then what you will be getting, that is equal to 1 AMU. What is that? 1 AMU. What is AMU? 1 atomic mass unit. 1 atomic mass unit. Nowadays, we are also represent this as a U, just U also. That's called a unified mass. This also I think we discussed in the previous classes in the volume 1. So 1 AMU. So 1 AMU is what? 1 atomic mass unit. Okay. How you are getting this 1 atomic mass unit? When you are taking the mass of carbon and you are dividing by 12, then you will be getting this 1 atomic mass unit. Clear? So if you want to express this in the grams, okay, this in the grams, okay, it will be very, very less. Okay, so here it is given, you see, the mass of one carbon is given as 1.9924. Okay, the mass of one carbon is 1.9924 into 10 to the power of minus 23 grams. Okay, so this you are dividing with the 12. Okay, on dividing with the 12, then what will be getting here is, okay, 1.66 into 10 to the power of minus 24 grams here we are getting. So this is equal to 1 atomic mass, okay, unit in terms of grams. In terms of grams. If you want to express the same thing in kgs, so just you divide by the 1000. So what will get here? That is equal to 1.66 into 10 to the power of minus 27 kg. Okay. So this is the okay, one atomic mass, okay, one atomic mass unit, one AMU in terms of grams, in terms of kgs. Okay, so it will be very difficult to calculate every time. Yes or no? So that's what simply what we do is we use a one atomic mass unit, one AMU. That's all. Clear to you? Okay. So that is about the one atomic mass. So here, if I say that carbon atomic mass is 12, atomic mass is 12, the meaning is what? Okay, 12 times of 1 AMU, 12 times of 1 AMU. If I say that oxygen atomic mass is 16, the meaning is what? 16 times of 1 AMU. If I say that sodium mass is 23, the meaning is what? It's a 23 times of 1 AMU. This is very simple. Instead of telling these numbers and this one, so it's very easy. So calcium, what is the atom mass number of calcium? 40. The meaning is what? Its mass is 40 times of 1 AMU. That's all. Clear? So this is about the relative atomic mass. Okay. So here 1 mole is nothing but a what is its mass number? That many grams. So calcium, 1 mole of calcium is what? It's what's the mass of 1 mole of calcium? Its mass number is 40, so 40 grams. And 1 mole of calcium consists of how many atoms? 6.023 into 10 to the power 23 atoms, same that is. Clear? So that is for atoms. For example, molecules are there, you think. For example, molecule, like water. This already we discussed, but once again. Okay. So molecular mass. Molecular mass of water I want. Water formula is what? H2O, right? So here to calculate what molecular mass of water, H2O, already we discussed molecular masses, but once again. So how many hydrogens are there? 2 hydrogens. 2 into hydrogens, right? How many oxygens are there? 1 oxygen. So 1 into oxygen. So that is 2 into hydrogen mass number is 1, right? And 1 into oxygen, this is oxygen mass is 16. So now how much it comes to? 2 ones are 2 plus 16 ones are 16 is equal to 18. So this is the molecular mass of water. Molecular mass of water. Now if I ask you, what is the gram molecular mass of water? Gram molecular mass. Then what I do? Just I will express this one in terms of grams. Okay. So that becomes 18 grams. So this is called gram molecular weight. Did you understand? Gram molecular weight or gram molecular mass. Okay. Now what can you understand from this gram molecular mass? Again here. So this is once again very important. So what you can understand from this gram molecular mass? So here 18 grams of water. It's a molecular mass of water. So if I take the 18 grams of water, and if I count the number of molecules, water molecules present in that 18 grams of water, how much I will get? Say 6.023 into 10 to the power 23. Clear now? Okay. So the meaning is what? Again, it is 1 mole. 1 mole of water is equal to 1 mole of water is equal to molar mass of water. 1 mole of water means what? Molar mass of water. Molar mass of water is what? How much we got here? 18 grams. So 18 grams of water consists of is equal to 1 mole. And you know that 1 mole is equal to 6.032 into 10 to the power 23. Clear? Now, in your material, page number, what is this? 95. Yeah. Page number 95, one more example is given, like sodium carbonate. Okay. So now see here, molar mass of sodium carbonate. What's the formula of sodium carbonate? Come on, fast. You have to say chemistry. Okay. Already we discussed Na2CO3. Right? So how many sodiums are there? 2 sodiums. So 2 into sodium mass is how much? 23. 2 into 23, how much? 46. Okay. Now 1 carbon. Carbon atomic mass is how much? 12. Plus 3 oxygens. Is oxygen mass how much? 16. 16 3 is a 48. Right. If I total count is how much I'll get? 106. How much I'll get? 106. So molecular mass is 106 of what? Sodium carbonate. Of sodium carbonate. If I want to express in grams, okay, so molecular, gram molecular mass, if I want to, just I put the G, so this becomes gram molecular mass. If I don't put G, it becomes only molecular mass. It becomes what? A molecular mass. So for molecular mass, there is no units, we are not writing any units. But if you are writing gram molecular mass, then you are writing 106 grams because they are expressing in terms of grams. So grams. Now what this 106 grams represents? 106 grams represent 1 mole of sodium carbonate. What it represents? 1 mole of sodium carbonate. Okay. So 1 mole of. So gram molecular mass or molecular mass of any substance represents 1 mole. Represents 1 mole. So but 1 mole of sodium carbonate, 106 grams of sodium carbonate means what? 1 mole of sodium. And 1 mole of sodium carbonate means what? It consists of 6.023 into 10 to the power of 23 sodium carbonate molecules. Clear to you? So that is about our lesson. Okay. So it's a very simple. So 1 mole is nothing but a fixed number, and that number is 6.023 into 10 to the power of 23. And if I take 1 mole of carbon atom means 6.023 into 10 to the power of 23 atoms. 1 mole of oxygen atom is 6.023 into 10 to the power of 23 oxygen atoms. 1 mole of pens means what? 6.023 into 10 to the power of 23 pens. Like that. That's all. 1 mole. Okay. But 1 mole of carbon mass is how much? It's atomic mass. Carbon mass. Atomic mass is 12. No, you know that. 1 mole of oxygen is how much? 16 grams. 1 mole of sodium, 23 grams, and so on. This is for atoms. If molecules, so 1 mole of water means what? H2O. So just calculate the total molecular mass of this one. So you'll get 18. So 18. So 18 grams of water means 1 mole of water. 1 mole means what again? 6.023 into 10 to the power of 23. Okay, students. So now that is about the gram mass, relative mass, molecular mass, or gram molecular mass, everything that we discussed. So now, here one more small topic is there about the isotopes and isobars. Already we discussed in the previous classes somewhere else, but once again I'll check, I'll discuss this one. Can you see now? Okay, I'll write here isotopes. Okay, so see now, I'll write here isotopes. Isotopes means what? Atoms of same element. For example, see carbon, carbon, carbon. All same atoms with the same atomic number 666. But if their mass numbers are differs like 12, 13, 14, then these are called isotopes. What they are called? Isotopes. Atoms of same element with the same atomic number but different mass numbers are called isotopes. And if you want to know how many protons, how many electrons, how many neutrons are there, very simple. Atomic number represents the number of protons. So 666. And electrons means what? How many protons are there? Same number of electrons will be there. Again 666. And now neutrons, mass number minus atomic number is the number of neutrons. 12 minus 6, 6. 13 minus 6, 7. 14 minus 6, 8. So these are the number of neutrons. So isotopes means what? Atoms of same element having same atomic number but different mass numbers. So same atomic number means protons, electrons remain same in isotopes, but neutrons will be changes. That's all. Clear? Chalo. Now similarly, isobars. Let us see the isobars. Isobar. What are isobars? Exactly opposite definition. Here what I said, atoms of same element. Just to make it opposite. Atoms of same element. You make same as different element. Having same atomic number I said here. So you make it different atomic number. Here I said different mass numbers, but you say that same mass numbers. So for example, you can see a example, what is given a material, okay, potassium and calcium. Okay, potassium and calcium, argon of potassium. Okay, they are given potassium and calcium. So potassium and calcium. Potassium atomic number 19, calcium 20. But if you see their mass numbers 40 and 40. Okay. So here, if you see the electrons, protons and neutrons, electrons and neutrons. Okay. Now, okay, first you see this one. So here, this is potassium, these are calcium. Are they both the same atoms? No, potassium is different, calcium is different. Different atoms. Atomic numbers you see 19, 20. Are they same? No, 19, 20 different. Mass numbers of 40, 40. Yes, both are same. So how can you define them? Atoms of different elements having different atomic numbers but same mass numbers are called the isobars. So here protons and electrons. Here protons 19, here protons 20. Electrons also 19, protons are 20. Okay, but number of neutrons, mass number minus atomic number. Here 21 neutrons, here 20 neutrons. Okay, so in this way we can calculate the electrons, protons and neutrons in any atom. Clear? So that's all. So with this topic is done. Okay, now here some questions come. Let's explore. Let's see here. The number of particles present in 1 mole of air is, just now I told you, 6.023 into 10 to the power of 23. So the answer is second option, 6.023 into 10 to the power of 23, the second option, right? Now, gram molecular weight of oxygen, already we discussed here, gram molecular weight of oxygen is 16 grams, okay? So the option is oxygen atom, oxygen gas they are given. Oxygen gas means what? The gas formula is what? O2. What do you write there? O2. Each oxygen is 16 to the 32 students, so the answer is 32. Okay, 32. Now 32 grams. Okay, so second one is fourth option. The element taken as reference in measuring the atomic mass. Just now I told you reference. Reference is carbon. Carbon C612. So option is second option. Second option is the right answer. Okay, to measure that. Okay. Now come to the fourth question. The weight of one carbon atom. The weight of one carbon atom is 1.9924 into 10 to the power of minus 23. So which option that is 23 minus 23. Yeah. So the option is B there. Okay. Numerical option is what? B. Right. Now 1 AMU equal to, so 1 AMU equal to, see 1 AMU is equal to 1.66 into 10 to the power of minus 24 grams or minus 27 kg. So what is there? Kgs. So fourth option, 1.66 into 10 to the power of minus 27. Molecular mass of the substance, if they express in grams, that's called gram molecular mass. If they express in grams, then that's called gram molecular mass. So the option is 2. Right? Next, the order of molecular mass. The order of molecular mass. So what is the order of molecular mass? Generally between 10 to the power of minus 24. Okay. Minus 24 and 22. So that's the right answer. So first option is the right answer. Now next one, eighth one, you see gram molecular mass of ammonium. So ammonia gram molecular mass is how much? Ammonia formula is NH3. You know that. NH3. NH3. Nitrogen atomic mass is 14 plus 3 hydrogens. Each hydrogen mass is 3. 14 plus 3 is equal to 17. So 17. 17 is the right answer. 17 AMU. That's a gram, no? 17 grams. So third option is the right answer. Atomic mass of a substance expressed in grams is known as, okay? So that is the gram atomic mass, just now we discussed. The sum of the relative atomic masses of all constituent atoms in a molecule is called the relative molecular mass, okay? This molecular mass, relative molecular mass, that's all, okay? So very simple, very easy questions are there. So today we have started the new topic, new concept, that is mole concept. Okay, this is the last chapter of your IIT foundation for 7th class, and we have completed one synopsis. 2 more synopsis has to go. So with this we complete our IIT syllabus. Right, students? So prepare well, don't waste your time, and this is a very important concept. It will be very, very helpful to you in your future classes. Okay, when you go to the 9th and 10th, if you follow the 7th and 8th year, okay, in our IIT foundation classes, then 9th and 10th it becomes very easy to you. And if you follow that 9th and 10th also, then when you go to the intermediate, okay, or 11th standard, 12th standard, then okay, you can easily, everything will be okay. I am saying if you are following our IIT foundation course, then almost 60 to 70% of 11th and 12th standard will be done, including JEE Mains. Okay, so that will be very, very helpful and useful to you. Okay, so that's what, don't neglect. So with this we stop. Bye.